The inverse normal distribution. So far, we have considered situations like that shown on the left. We have values of x, so in this case, we're going between a and b, and we calculate the probability using either the 68, 95, 99.7 rule if we don't have a calculator, or the normal CD function on the calculator, as we've seen in the last few examples. The situation on the right is different. We know the area is 0.9, so we're being told that this area is 0.9, and it goes from x all the way back. But we want the value of x. We want to know the number here. So it's different. Here we know these numbers, and we want to find the area. That's how we find the probability, and that's when we use normal CD. Here we know the area, but we want to find this number. And that requires the use of the inverse normal function, which we can find on the calculator. And we'll see this over the next few examples with the calculator, the emulator. So we're going to select statistics again. We're going to select distribution, and we're going to select normal. Notice we talked about these before. The normal PD, that just gives you the height of the curve at any value you put in. I can't think of any reason you're going to need to know that. The normal CD we've been using, which gives us the area between two values like this. And then the inverse normal, the one we're going to talk about now, is just there. So when you're in there, it says inverse normal at the top, and it's going to ask you for a tail setting. The one that we were talking about above was a left tail setting because we had a value here and then the area went to the left. You have also the option to have your tail going to the right, and the other one that it does is center, and that one is symmetrically about the center. So for example, going from -1 to 1 standard deviations. So we've got left, we're using a standard normal here. We can see 1 and 0. The area is 0.9, and then you calculate just by hitting execute on your calculator. We'll see this in the examples that follow. And so we have evaluated that our Z here is 1.28. The tail settings on the inverse normal, and we've just mentioned this, are left, as shown above in the example, right, see below, so this one here, and symmetrical about the center, like this one here.